Starting from rest at A, block reaches at B in the first 2 seconds. Find the coefficient of kinetic friction between the surfaces. The free body diagram of the block is shown in the figure. The kinetic friction is acting in this direction because block has tendency to move, or it is given in the question that it is moving in this direction. So kinetic friction will be in this direction. This is shown here. Mass is here, and this is theta. So this will be theta, and component in this direction mg cos theta, and component in this direction will be mg sin theta. Normal friction will be in this direction. Normal normal reaction in this direction. So we can write mg sin theta minus f equals to ma, and this will give a equal to mg sin theta minus, because kinetic friction is given by mq into mg cos theta by m, because we have formula fk बराबर fk equals to mk into n, so n is here equal to mg cos theta, so mk into mg cos theta. Now this will be equal to g sin theta minus mk into g cos theta. Now we have formula s equals to ut plus half at square. Here s equals to l and u equals to 0 because it is a starting from rest, and t equals to 2 seconds given in the question. So we have and a equal to g sin theta minus mk into g cos theta we have calculated. So using this value in this formula, we get l equals to half under bracket g sin theta minus mk into g cos theta into 2 square. This implies L by 2 equals to g sin theta minus mk into g cos theta, or this implies mk into g cos theta, this part taken in this direction, g sin theta minus L by t. Hence mk equal to taking this g cos theta in this side. So we will get mk equals to tan theta minus L by 2 g cos theta, and now the value is given. So putting all given value, we get the mk equal to 0.106, which comes out to be 0.11. In the above problem, if block is pushed with a force of 4 Newton, how far block will move in first 2 seconds? Mass of block equals to 4 kg. Here is same problem, but only flat force is acting on this. Now free body diagram is shown in the figure, so we can write f plus mg sin theta minus fk equals to ma equation of motion. So a equals to f plus mg cos theta minus mk into n by m, or f plus mg sin theta minus mk into mg cos theta divided by m. Now s plus half it is square, here e equal to 0. So we can here s equal to l and u equal to 0, t equal to 7, so and a equal to this value. So we have l equal to 1 by 2 under bracket f plus mg sin theta minus mg cos theta by m into 2 square. Putting all given value, we get the final value equivalent to 10.0948, equivalent to 10 meter answer. Next, in above problem, if force F is applied as shown in the figure, then find A acceleration of the block of the plane. This is the figure shown, and a force is acting in this direction, and mass of block is 4 kg, and applied force has value 4 Newton, and this is theta equal to 32, and mu is given 0.11. Here free body diagram is shown in the figure. This line is taken as x-axis, and this line is as y-axis, and because mass is acting in this direction, that is weight in this direction, so its component in this direction will be mg cos theta, and component in direction will be mg sin theta. Similarly, force is acting like this. So if it is theta, it is 90 minus theta, this will be again theta. So in this direction applied force will be F cos theta and the direction will be F sin theta. And normal reaction on this body is in this direction. Now taking shift, because body is not moving in this direction, so we can write sigma Fy equal to 0. Or this gives n equals to F sin theta plus mg cos theta. This is equation 1. Again Fk equals to mu k into n, so we can write mu k into here. The value of n is equal to F sin theta plus mg cos theta. So we can write mu k into n F sin theta plus mg cos theta. This is equation 2. Now for the x direction, if we write sigma fx equal to ma into x, because we have assumed that body is moving in upward direction, so we can write the equation of motion F cos theta in this direction is F cos theta minus mg sin theta or minus fk equals to ma. This implies F cos theta minus mg sin theta minus mu k into F sin theta minus mu k mg cos theta equals to ma. Or this implies A equals to F into under bracket cos theta minus mu k into sin theta minus of mg into sin theta plus mu k into cos theta divided by m. Putting all given value, the final value comes out to be minus 0.139 meter per second square. And here negative sign indicates that F is not sufficient to move the block upward. Now suppose block move in the downward direction, then um, only force of friction, that is kinetic friction, will be acting in this direction and all other forces will be in the same direction. So we can write Fk equals to mu k into n, or this equals to mu k into F cos theta plus mg cos theta, or putting the value we will get the value of this as a 0.22 into about 4.03 Newton. So Fk is in this direction and mg sin theta in this direction. Now mg sin theta equals to 20 Newton, because force in this direction is 20 Newton. Hence A will be equal to 20 minus 4.03 by divided by 4 equals to 4 meter per second square. Yeah, find the force parallel to inclined needed for block to move up the plane and to down the plane. This is the situation here. A mass of the body is given and coefficient of friction is also given 0.2. Now when body force of friction F max, that is force of maximum force of friction is FL, that is mu s into n or mu s mg cos theta. Putting value we get 3.39 Newton. Now force acting down the plane is FD equal to mg sin theta equals to 9.8 Newton. This FD, that is this force, is greater than FL, so body move in the downward itself. So no force is required. So no force is required to move the body in the downward direction. Now when body moves up, the plane, force of friction start to act in the down the plane. So force required to move the block up the plane equals to F equal to mg sin theta plus F equals to mg sin theta plus mu s into mg cos theta. It is minimum force and equal to 9.80 plus 3.39 about 13.19 Newton answer. In the above problem, find the horizontal force required to move the block up the plane. Here it is shown. So we take the component of F. This will be F sin theta and this will be F cos theta. Weight of body will be in this direction mg sin theta, in this direction mg cos theta. Normal reaction will be in this direction. So here n equals to mg f sin theta plus mg cos theta. Now force of friction F barabar mu s into m, mu s into f sin theta plus mg cos theta. In limiting case f cos theta should be equal to f plus mg sin theta or mu s into f sin theta plus mg into cos theta plus mg sin theta. This implies f cos theta equal to f into mu s sin theta plus mu s into mg cos theta plus mg sin theta. Or this implies f equals to f into under bracket cos theta minus mu s sin theta equal to mg into mu s cos theta plus sin theta. Hence f equal to mg into under bracket mu s cos theta plus sin theta divided by cos theta minus mu s sin theta. Putting all value, the all value here, we get the different value. Finally we get 17.22 Newton, that is 17 Newton. Next, find the acceleration of the boy. Here mu given 0.6 and g equal to 10 meter per second square. Again the free body diagram is drawn, and in this direction mg cos theta, this is mg sin theta, and force of friction will be in this direction equal to mu m. Now sigma fx equal to ma into ax, so mg sin theta minus f equal to ma, mg sin theta into mu mg cos theta equals to ma. Since f barabar mu mg cos theta, hence a equal to mg sin theta minus mu mg cos theta divided by m equal to this g sin theta minus mu g cos theta. Putting all value, we get the value of a as 2 root 2, about 2 into 1.414 equals to 2.828 meter per second square. So the boy has acceleration 2.828 meter per second square. Now s barabar ut plus half it square, given u equal to 0, t equal to half second, and s equal to 1 by 2 meter. Hence 1 by 2 equal to 1 by 2 a into half square, equals to 1 into 1 equals to a by 4. This implies a equal to 4 meter per second square. Now v equal to u plus at, so vv will be 4 into 1 by 2 equal to 2 meter per second, and s equal to a2 plus half its square considering from initial point A. Here s is equal to 1, u equal to 0, t equal to t dash plus 1 by 2, and a equals to 4. We get 1 into 1 by 2, 4 into t dash plus 1 by 2 ka whole square. This implies t dash plus 1 by 2 ka whole square equal to 1 by 2, or this implies t dash plus 1 by 2 equal to 1 by root 2, and t dash 1 by root 2 minus 1 by 2. Putting all value, we get 0.21 second answer.